Assalamu alaikum warahmatullah. Today we'll learn about the classification of the second order partial differential equation. This classification is basically motivation that is generated by the classification of the quadratic equation of the general form. If you remember, if you recall, the quadratic equation of the general form for two variables is ax square plus bx into y plus cy square plus dx plus ey plus f is equals to 0, where you have two variables x and y, and a, b, c, d, e, f, they all are the arbitrary constant. So the classification of that second order or quadratic equation was basically as if you take a discriminant of b square minus 4ac, that is b square minus 4ac. That means you can see here we just need these three terms right now. Rest of the terms, since this is the classification of the second order equation, we just need a, b, and c, the value of a, b, and c. So basically this classification with respect to the discriminant b square minus 4ac will be as if the value of the b square minus 4ac, if you evaluate b square minus 4ac and you found that the value of this b square minus 4ac is equals to 0, so you can say the equation is parabolic. If this b square minus 4ac, the value of the b square minus 4ac is greater than 0, you can say the equation is hyperbolic. Similarly, if the value of the discriminant is less than 0, you can say the equation is elliptic. So basically, we have these three conditions of the discriminant that if the equation discriminant is 0, we can say the equation is parabolic. For greater than 0, hyperbolic, and that for the less than 0, it's elliptic. The similar thought or similar requirement, similar calculation being done for the partial differential equation of second order. Second order partial differential equation can be represented as a uxx, where you can see I write uxx. That means a second order partial derivative of u function with respect to x only. Similarly, plus b uxy plus c uyy plus d ux plus e uy plus f is equals to 0. So you can see here that the second order partial derivative with respect to x is represented as uxx. You can see uxy is basically the second order partial derivative of your u function or u variable with respect to x and y. Similarly, uyy is representing that second order partial derivative of u function or u variable with respect to y only. And the first order derivative where ux is basically the representation of the first order derivative of u with respect to x. uy is represented as the first order derivative of u with respect to y. And f is just an arbitrary constant. Okay. And not only f, basically, here you have a, b, c, d, e, and f. They all are the arbitrary constants. So the discriminant, the evaluation of the discriminant is same here. You just have to evaluate the discriminant for that is equals to b square minus 4ac. So basically, the same thing is that we just need these first three terms to evaluate the discriminant, since we just need the value of a, b, and c. For the evaluation of a, b, and c, you can see here these three terms will be required only. So after the evaluation of the discriminant, if the values are equal to 0, we can say this partial, like this second order partial differential equation is parabolic. If the equation, if the discriminant is greater than 0, then you can say this second order partial differential equation is hyperbolic, and if the value of the discriminant is less than 0, you can say this second order partial partial differential equation is elliptic. So this is basically the general working of this partial differential equation. Now हम कुछ इसकी एग्जांपल्स करते हैं. लेट्स सपोज कि इसको देखते हैं किस तरीके से हम फर्दर लेकर कंटिन्यू कर सकते हैं इन तमाम चीजों को, किस तरीके से हमारे पास जो है वो एग्जांपल्स आती हैं. Okay, let's suppose you need to classify. The question is you have to classify the following partial differential equation, and these partial differential equation are basically the second order partial differential equation. Remember that these classification are we are discussing these classification of a second order partial differential equation. Let's suppose the differential equation is 3 times uxx plus 10 times uxy plus 3 times uyy is equals to 0. Now here you can see that you have only these in comparison to, if you compare the above equation by the general equation as uxx a uxx b uxy plus c uyy plus d ux plus e uy plus f equal to 0. You can see here we have only these 3 terms to compare. So the value of a in comparison to the given equation is basically 3. The value of b is equals to 10, and the value of c is equals to 3. This comparison is basically like a is equals to 3, b is equals to 10, and c is equals to 3. So basically we have all the values of a, b, and c. Rest of the values are 0 here for this case. D, E, and F are 0, but for evaluation of the discriminant, we don't need the value of D, E, and F. So basically, the value of the discriminant, that is b square minus 4ac, will be 10 square minus 4 times 3 into 3. So you will have 100 minus 36. So the answer will be basically 64. That is greater than 0. For greater than 0, you can say the given equation is given partial differential equation is hyperbolic. So basically this given partial differential equation is hyperbolic. Similarly, if you consider any other, let's suppose any other equation, as you have to classify the differential equation as x square uxx minus 2 into x into y uxy plus, let's suppose, y square uyy is equals to exponent of x. So this basically exponent of x right now is like f function, but we don't need this value of f here. So we just concerned with the value of a in comparison, the value of a. This is the value of a. Similarly, the value of b here, you have the value of b, and the value of c. This is the value of c. Rest of the values are not used in finding the discriminant. So the discriminant is b square minus 4ac. You'll have minus 2x into y whole square minus 4a. The value of a is here x square, c is y square. So you will have 4x into y square, 4x square into y square minus 4x square into y square. So your answer is 0. So if the answer is the value of the discriminant is 0, we have said this equation is, given equation is parabolic. This equation is parabolic in nature. We have the solution, like the first equation was hyperbolic, the second equation is parabolic. Maybe for some another example, let's say if I say you have uxx minus 2 times of sine x into uxy minus cos square x into uyy minus cos x into uy is equals to 0. Again, saying the same thing, okay, we just need only these three values, the second order derivatives, the coefficient of the second order derivatives in an equation. So the coefficient of A is 1 here, the coefficient B is minus 2 times sine x here, and the coefficient C is basically minus cos square x. So we just have to evaluate the discriminant as the discriminant will be equal to b square minus 4ac. So you can evaluate the discriminant as minus 2 times sine x whole square minus 4a. The value of a is 1 here, and the value of c is cos minus times cos square x. So the answer will become 4 sine square x plus 4 cos square x. You can take 4 as a common, and sine square x plus cos square x remain. And by the we know that this is the identity, this is the trigonometric identity, that is equals to 1. So you will have the result that is equals to 4 only, that is greater than 0. The greater than 0 is representing the given equation. This given equation is basically hyperbolic. So we have discussed these three equations. One is hyperbolic, the one is parabolic, and the third one is also hyperbolic. Let's take an example for the elliptic equation. Let's suppose if I say, let's consider again an example. You need to classify 1 plus x square of uxx plus 1 plus y square of uyy plus x times ux plus y times uy is equals to 0. So we can see here the value of a in comparison to the second order derivative with respect to x only is 1 plus x square. The value of b is 0 here, since we do not have any coefficient of uxy. The coefficient of uxy is basically b, and it's not present in the given equation. So we can say the value of b is 0, and the value of c is basically 1 plus y square. So you'll have the value of a, b, and c. Rest of the values are useless for evaluating for the classification of the second order partial differential equation. We just need the value of a, b, and c. Actually, I was repeating this sentence in every example because sometimes students get confused to evaluate the value of b, a, b, and c. You must know that we are classifying the second order partial differential equation. So we just have to evaluate the value of a, b, and c, that are the coefficient of the second order derivative, second order partial derivative. Rest of the arbitrary constant that are d, e, and f are basically the coefficient of the first order derivative or the zeroth order derivative. So basically we have the values of a, b, and c as 1 plus x square, 0, and 1 plus y square respectively. We are just evaluating the value of discriminant here as b square minus 4ac. So you will have 0 square minus 4a. The value of a is 1 plus x square. The value of c is 1 plus y square. Now the answer is minus 4 times 1 plus x square into 1 plus y square. So it's a general answer. You need to conclude with respect to the values of x and y. Let's suppose in this scenario, let's suppose if the value of x is positive and the value of y is also positive, what will happen? This will become totally, the final answer will be in negative, that is less than 0. Whatever the answer is, if the value of x is positive, value of y is also positive, the final answer of the discriminant is still in negative. So negative, that is less than 0. So your equation is elliptic in this case. So let's suppose in another working, let x is negative and y is also negative. So in this case, again, the value of the discriminant is again negative, since you have x square. So value of the negative will vanish, and the result is also positive for 1 plus x square and positive for 1 plus y square. But this negative sign, basically this negative sign will lead to the answer a negative value. So this is also 0. The equation is elliptic for this one. Now let's suppose x is positive but y is negative. What will happen? The same result, you will obtain the same result. You'll get similarly for this last case, last possibility, that x is negative and y is positive, you'll get the same result as the discriminant will remain in negative. So the equation will be said to be elliptic still. And let's suppose one another example, that x is 0 and y is 0. What will happen? Still the equation, the value of the discriminant is negative. So the value discriminant is less than 0. The equation will remain elliptic. For all the cases, since the equation is elliptic, you can say in general, this equation, the given equation is elliptic. So basically, these are the examples of the classification of second order partial differential equation. I hope this is one of the easiest topic to classify how we can classify the second order partial differential equation. In the next lecture, we'll learn about the method of separation of variable. Inshallah. Thank you. Allah Hafiz.